Next, I won't butcher Warren's last name here, but Warren is our next speaker. He's the founder and CTO of Autimo. He's a solutions architect and cloud engineer with expertise in cloud infrastructure, DevOps, and software development. Warren is passionate about simplifying complex technologies, and he likes to offer, one of the things he does is offer practical insights on building scalable systems and inspiring innovation in the cloud. So please give a hand to welcome Warren.
Thank you. Welcome everyone. My name's Warren Uniewski, and I am the CTO at Autimo. At Autimo, we're a small cloud consultancy, and we help people build and manage their infrastructure in the cloud. So today, what I would like to talk to you about is, let's get that up there. I would like to talk to you about a challenge that a lot of our teams face, and that is a flood of alerts. These flood of alerts come in constantly, they take our attention, and they cause fatigue. And so I would like to discuss and explore a world where these alerts are no longer a source of interruption, but instead enhance our productivity. So how can we do that? So I'm going to briefly talk about what we're going to look through today. So I'm going to reintroduce my vision for how we can take these alerts and transform them from raw data into actionable insights. We're going to talk about the alert challenge. So what is the scale of this challenge? How big is it? How many alerts do we get? We're going to talk about how generative AI can be used to solve this problem, or at least help mitigate it. And then we're going to talk about some future possibilities for this technology. All right, let's dive in. All right, so to frame my vision for generating actionable insights from our alerts, I'd like you to imagine a world where every AWS alert that comes in isn't just an interruption, another notification for us to investigate, but instead it's a comprehensive actionable insight, something that can allow us to immediately take action, and it's delivered right into the workflow where we are doing our day-to-day work. So before we begin, let's talk about the scale of the alert challenge that we have. And in order to do that, I'd like you to imagine a typical day for a team, an operations team where they have a constant sort of trickle of alerts coming in. These alerts might be minor performance fluctuations, they could be spikes in error rates, and they could also be warnings about approaching resource limits. Not all of these are critical, but they all demand your attention. And so, the result of this is that we have information overload, there's time-consuming triage, and we have compromised application and system reliability when we don't action the alerts that are critical. So AWS provides powerful monitoring and alerting tools. However, the volume of alerts can be overwhelming, and this leads to fatigue. So according to a PagerDuty study, 38.5% of teams receive between 100 and 500 alerts weekly, and almost a quarter of teams receive over 500 alerts weekly. So this does lead to alert fatigue and can create internal friction, job dissatisfaction, potentially even leading to turnover. I also want you to consider that if you're receiving 500 alerts a week, and each one of those alerts takes on average 5 minutes to just triage and investigate, just at surface level, then that means we're spending over 40 hours a week just triaging and investigating the initial investigation of these alerts. So in addition to that, determining the root cause of these problems and diving deeper into them often requires piecing together information from multiple sources. This leads to frequent context switching and can really decrease productivity. So this flood of alerts can compromise our system reliability. Only 50 to 60% of alerts are actively investigated. On top of that, between 30 and 70% of alerts are false positives, depending on how well you've tuned those. And what these two things combine, so the lack of investigation, the false positives, they come together to cause us to miss genuine critical issues. So the consequence of this overload does lead to significant problems, and 80% of DevOps teams admit to ignoring alerts to some degree. This increases the risk of missed critical issues, resulting in system performance degradation and potential downtime. So I just want you to take a look at this. This is a real simple diagram of a potential alerting system, but it's quite common today. You have your application in that dashed box. Maybe you're collecting CloudWatch metrics and logs, and then setting alarms based on those. But I do want to say that it's not just application metrics, and CloudWatch alarms. These could be security hub findings or lots of other types of alerts as well that are feeding into these systems. And typically, when we do have some sort of alarm, we want to notify people about it, right? So we send those to our Slack or PagerDuty, and this takes our developers out of their workflow. It interrupts them, and it forces them to go to external systems where they may or may not have access. If you're working with sensitive data, not all developers may have access to that data, and so that causes even more friction in resolving that issue. So this is where we are today. I just want you to keep that in mind. And now we're going to talk about how generative AI, this is a technology I think we've all seen, how it's revolutionizing the way we process and understand information. And in the context of AWS alerts, generative AI means that we can transition and take raw data and transform it into actionable insights, things that we can immediately start working on. We can take those insights, we can deliver them directly into our workflow, and by that I mean into our project management tools like Jira, or onto GitHub issues where the developers can start to action them immediately. And so by seamlessly integrating these insights into our workflow, we can increase our productivity, decrease interruptions, and increase satisfaction in the work that we do. So how do we transform these alerts into insights, meaningful insights? Well, there's three main steps. The first step is the data collection. We have to remember that these large language models, while powerful and trained on a lot of internet data and very smart at coding and knowledgeable of AWS, they do not know about our specific system or the specific state of our system. And so we need to do as good a job as we can to provide them with that context. That means going out and grabbing system logs and metrics and all that sort of stuff. We can then use that as context to feed into the model. And what I mean by feeding into the model, this is something, say, like Amazon Bedrock, like you've seen Gabriel talk about earlier today. And I'm later going to show you a sample application and use case that does use Bedrock and Anthropic Claude Sonnet 3.5. It's a very good tip to always start with that top-level model and then see where you can go from there. But yeah, you take this data and you send it to the model. And how do you send it to the model? This is where the prompting comes in prompt engineering. So you have to think about what your goals for the output are. Is this creating a GitHub issue? So what does a typical GitHub issue look like? How do we create them? Are there standards that we already have in our organization? We can reuse those. And so once we send the context, all that data about our system that we've collected, we can prompt it for the appropriate use case, and we can get back data. Now, I like to prompt models in ways that give me back structured data. Structured data is really useful because we can continue to use our regular programming paradigms rather than having to dig through unstructured text. And once we have that structured response, we can then use that to deliver it to any system, really, that we want. It might be, like I said, Jira or GitHub issues, but it could be any other sort of productivity workflow tool that you have. So yeah, you should really be creative with these sorts of things. So digging a little deeper into the data collection side of things, let's just talk about a few of the things we might want to collect. So obviously error logs, if this is an error, some sort of application failure. Maybe it's not a failure. Maybe it's a performance issue. Some performance metric is out of bounds. So we want to collect the system metrics for that state of the system. We might want to collect application code, so the large language model can help us identify and troubleshoot the issue. Maybe there's been a recent change to the code that's introduced a regression or a new bug. So all of that would be useful information in helping our developers, who are the ultimate recipients of this information, investigate these issues more rapidly and productively. Another thing that we can do is we can use our existing issues as a source of information. So if there's other relevant issues that have happened in the past and they are related to this current alert, we can use that, the model can use that as context. We can also use relevant documentation from our documentation stores. And we can query these in retrieval and use them for retrieval augmented generation, using things like Amazon Knowledge Base. One thing that's really interesting about those last two pieces, the existing issues and the relevant documentation, is this is sort of like a positive feedback data flywheel. Once we generate insights with these systems that have produced good insights and are in our past issues, they can then be used again to be retrieved and help improve this system over time. So we can get better insights, better results from our models as we continue to use these. So the GenAI-powered analysis, this is really simple, right? We've already talked about this. This is literally just using something like Amazon Bedrock, which has a number of models available. Again, using something like Claude Sonnet 3.5 today is a good starting place because that is one of the best performing models in terms of reasoning and coding and all that sort of stuff. We prompt that model like I talked about before, and we think about what types of data we want to have returned to us. Another thing I'd like to mention is that not all types of alerts will require the same level of reasoning. You can get creative in terms of saving cost by saying, okay, this type of alert doesn't need Claude Sonnet 3.5. We can use Haiku here, right? And we can save some money. So we could have some sort of classifier in that stage that will help us send it to the right model and ultimately save us money, maybe decrease our latency. So once we end up getting that data back, and we talked about how that's structured data, in the sample application that I used, that I'm going to show you and kind of walk through, that uses a library called Instructor. I love it. It's a Python library for getting structured data back using Pydantic models. However, there are lots of other APIs out there in models that help you get structured data back. That's not the only one. So when we're thinking about what system we're going to put this in, is it going to Jira? Is it a GitHub issue? What does that data look like? That will inform what sort of Pydantic model, in this case, we should build. So what does a GitHub issue look like? Quite often there's going to be a title, the body, and the body's got all the information in it, but it'll also have labels, right? So we might want to label it as a bug. We might want to label it as a performance issue, or we might want to label it as, it's part of this is something to do with infrastructure. Now this is an application issue. Or even this is a duplicate, or this is a false positive. So anything we can do to help triage that alert, send it to the right team, and help us get through this noise quicker. So the types of things I like to have in a GitHub issue are a good description. Again, we talked about those labels. Relevant context. So this might be a relevant piece of code that was involved in creating the error. This could be the log itself, if there's error logs involved. We really do want the model to give us a potential root cause if it can, and suggest a solution if it can. If it can't suggest a solution, wouldn't it be great if it could tell us some suggested next steps to further that investigation? Okay, so now I'm going to just briefly talk about the system, the sample application that I have. And in the sample application, we have a GitHub repository, and I will provide the QR code link at the end. So if you guys are interested, you can go in there and fork it and play with it and have a look at what it does. But I'm briefly going to describe it so you can understand all of the components. So this is a little bit of a simplified model, but the application is on the left. It's very, very simple. It is an API gateway that triggers a Lambda. The simplest application you can build for a POC. So this Lambda is expecting some JSON, and with one field in the input, when you post to it, that field is error. If the error field is set to false, we return hello Lambda, and we're all happy, and it's nice. If the error field is set to true, it intentionally raises an exception, and we get an internal server error. So this internal server error now will cause our CloudWatch log subscription filter, which has been set up to monitor our log group for that Lambda for errors. And when it finds one, it triggers that GitHub issue creator. This GitHub issue creator is the nexus of the application of the thing, of those 3 steps that we talked about. So once that's triggered, it's going to go off, it's going to do the data collection, and it's going to send the data to Bedrock, and it's going to then take that structured data it gets back, and it's going to create a GitHub issue with that. So in this sample application, what we collect is the error log. The CloudWatch log subscription filter event gives us that for free. But then we also go and collect the code. So in this example, what we do is we know the Lambda name. So we actually download the Lambda code directly from the Lambda. We can guarantee that this is the actual code that caused the error because it's coming from the Lambda that caused it. However, you could get creative with this. You could put tags on your application Lambda that say, this is the repository it lives in. This is the folder in that repository it lives in. This is the version. And then, your sort of issue creator system would have that information. Could use it to get that and provide more context. What this sample application doesn't do is it doesn't do some of those more advanced features I was talking about, like collect system metrics, system state, but that could be very useful. You might want to know, did my Lambda run out of memory? What was the disk I/O? What was the throughput? All those sort of things, and those can be very useful in helping diagnose an issue. It also doesn't do any of that RAG on the existing documentation, but I would love to see you guys take it, fork it, and add all of that. I think that'd be really cool. I'm not going to show you a live demo per se. I'm going to show you because it's very simple. I type in a curl command, I hit enter, and out pops a GitHub issue. But if you would like to see a live demo and dig into the code in detail, come see me after. I'll be around for a while, and we can jump on a laptop and go through some stuff. Okay, so what does the input look like? The input is a post to an endpoint. Very simple. Once we've done that, the Rube Goldberg machine that we've kind of set up here kind of chunks away, sends the data off to Amazon Bedrock and to Anthropic's Claude Sonnet. We get the structured data back, and we create a GitHub issue. So here we can see that the GitHub issue title is pretty good. It says an intentional error was generated in an example Lambda function. So the code itself didn't say that at all. The model was able to intuit that just from the structure of what happened. So I thought that was pretty interesting. We can also see that it's generated some labels. So I told it to generate labels. I didn't tell it to restrict that at all. It kind of just freewheeled those. It chose bug, error handling, needs investigation. Those are all pretty good. But in a real production system, you probably don't want it creating hundreds of just labels all over the place. You might want to constrain that to the labels that you use in your organization. We can also see that it created what is like a very good-looking GitHub issue. This is something that you would expect to have. It has a problem description, expected behavior, the actual behavior. It gives some analysis of the error, and then it also talks about potential solutions. And that's all really cool. It then tells you some additional context. That area would be definitely a lot more full if we provide some system metrics and some other things. And maybe some steps to reproduce. That's really useful. And then the code snippet of the actual line of code that caused the error. And I think it would be really cool if you're using those, the issues and the documentation RAG, because they could actually put links to those relevant documentation and issues right there, and that would really help our developers get to the bottom of the issues even faster. Okay, so now I'd like to talk a little bit about where we can go with this, because this is really just the beginning. This technology is brand new. There's lots of people working in this space. There is, Amazon Q is all over this space, and I'm sure it's going to definitely expand to take on a lot of the things I've talked about here today. And that's awesome. We need more tools like this, and And another tool that's very common in alert aggregation is Sentry. I'm sure some of you are familiar with that. They're also bringing in some of this generative AI technology. We have Randoli here today, who's a sponsor, and they work in this sort of space, but for Kubernetes. And I think that's super cool. So I'd love to see any work that we can do together to make all of our lives easier and take away some of that mundane work and let us do the meaningful work we know and love. I think that's great. So I'll just quickly run you through some of these and explain what I mean. So intelligent alert aggregation. Not all applications are as simple as the one I put up on the screen there. Some of them are distributed, some of them are microservices, and one error can sometimes lead to another. And so we can end up having errors in clusters and bunches, and that produces even more noise. So if we could use this same sort of methodology but expand it to group and cluster our alerts into a single issue, that will help our developers be even more productive to get a holistic view of these complex systems. So yeah, that's that one. I think contextual runbooks are a really cool area too. So when we build runbooks, we often build them as an operations team for things that we do over and over. And we often don't get to building out guides for things that don't happen as frequently. Well, with generative AI, we can allow it to recognize certain things, develop runbooks for those infrequent states. So for instance, when a system is in this state and this alert happens, I need to do X, Y, and Z. That could be like, when the disk is getting full, I should run this script to clean it. All right, so we could have it automatically generate these runbooks and suggest them for the types of situations that we're in, and then automatically provide them to us as part of the alert. Natural language querying for system health. This is definitely an area where Amazon Q is experimenting. But we can build essentially chatbots to chat with our system. This can include our issues, our documentation, the real state of our system, the logs, what were the recent errors, that sort of thing. I think that's really cool. And automated postmortems. Quite often, it's a lot of work to put these together. Some of the conversations happen in real life or in our chat programs, and we have to go back and compile all that. If we can be disciplined enough to have those conversations in the issues and in the systems of record, then we can use the generative AI to automatically create these postmortems. The issue might have the conversation that led to a pull request that led to the resolution, and now generative AI has all of the context it needs to generate that postmortem. And I think by having that carrot there at the end, it would help us all be a little bit more disciplined in doing, having our conversations in the systems of record and making sure we put that information in there. And lastly, this is probably the one that you guys were all thinking of right from the start, automated resolution. So this could mean using the issues that we've created as input to create a pull request with generative AI. And there's a lot of companies in that space that you'll see GitHub Workspace has that, and there's a number of other people working in that space. So this will supercharge that process. If we can generate actionable insights for our issues from our alerts, then we have half of what we need to generate a pull request with generative AI. Also, not all issues are application code related. They don't all need a pull request. Some things might be, again, going back to a disk filling up. It might be that we need to run some sort of playbook or script. So I'd just like to kind of recap and talk about some of the things we've talked about here. We've seen how traditional alerting can overwhelm us when it's not tuned correctly. We've explored how generative AI can transform those into actionable insights. And we've demonstrated a practical implementation, although very simple, that uses AWS services like Amazon Bedrock and GitHub Issues to complete that whole cycle. We've also talked a little bit about some future possibilities, and I'd love to hear your thoughts on what the future possibilities are to keep that discussion going. And I think by implementing this generative AI approach, we can significantly reduce that 10 to 15% of time we spend on alert triage and investigation. And this will allow us to focus on innovation and meaningful work. And moreover, we can address the alert fatigue that we get by these systems generating so many alerts, and we can improve the reliability of our systems by not missing critical issues. So I do encourage you all to explore this approach with me. This is not, a specific implementation or anything like this. This is really a conceptual idea that I would love to explore with all of you. In order to do that, there's the link on the left is for the GitHub repository. And the link in the middle is for a Discord community where we can have discussions about it. And so I'd really like to keep that conversation going and hear your ideas. And additionally, sometimes at Autimo we get together in real life and have those conversations as well. And we do that at a thing called Friday After Work Beers here in Vancouver. And so if you want to know of when those are happening, join that Discord community and you'll find out. So with that, I'd just like to say thank you very much. It was a pleasure.
Thanks, Warren. Thank you, Warren. We've got time for one question here. One I had was upvoted was, how can GenAI be leveraged to create tangible value for organization of data while still ensuring ethical use and data security?
Yeah, I think that's the question that's top of mind for everyone, and I don't think that there's necessarily one answer that can cover that across all domains. I think a lot of organizations have specific needs, different levels of comfortability with the data they expose, and I think we do need to be mindful. So we need to constantly be reassessing that. I think we've all already seen that we have had tangible benefits already, even if they're not directly integrated into our code bases. They're integrated into our day-to-day lives today. So this isn't going anywhere. You're absolutely right that we do need to be mindful about these ethical considerations, about the biases they impact, and how they influence us. So yeah, I don't think that any person has one answer, and you've seen these largest companies wrestle with this. I'd love to hear your thoughts on that and have that conversation, because I don't think there's an easy, simple answer.
Where do they go to get that from you? From out in the lobby then, to get the conversation going there? Or?
Absolutely. Come out to the lobby. I'll be up at the booth. And also, if you want to, after today, when we're no longer all together, you can go to the Discord community and we can have some chat there.
Sounds good. Thanks, Warren.
Thank you.